Look at this image. This is a newly discovered early galaxy that existed about 13 billion years ago, but researchers found that this galaxy far more massive and mature than expected for a galaxy in the infant universe. Well, this is not the first time that Webb has found such galaxies in the early universe. Ever since the Webb telescope began its journey, it has been challenging our standard cosmological theories. Well, the amazing telescope did not stop here. This time, this telescope has revealed a worrying thing about the universe. Recently, Nobel Prize-winning scientists revealed that the James Webb Telescope has finally confirmed that our understanding of the universe was completely wrong. Well, it is not about big and bright galaxies, but this time, some more important and new observations from the James Webb Telescope have shattered the age-old cosmological theories. Let's consider this. One of the pillars of cosmology is that the spatial distribution of matter in the universe is uniformly isotropic. It means that everything looks the same in all directions if you look over large enough distances. This is obvious, since the forces are expected to act equally throughout the universe on a large scale, and should therefore produce no observable inequalities in the large scale, structuring over the course of evolution of the matter field that was initially laid down by the Big Bang. Wherever you look, you will find the same density of matter, the same temperature, and the universe is expanding equally everywhere. For more than a century, scientists have been developing various cosmological models with the assumption that our universe is uniform in all directions. The Big Bang model, which is the best theory to understand the universe, is also based on this assumption. The cosmic microwave background radiation also shows that the universe is the same everywhere. But a recent study published February 6th in the Astrophysical Journal Letters suggests that there may be something seriously wrong with this assumption. Recently, astronomers have confirmed that the expansion rate of our universe is not the same everywhere in the universe. In this paper, they revealed that depending on where we look, the universe is expanding at different rates. Well, this is a big problem now because if the universe is expanding at different rates in different places, then it will create a major problem for astronomers. This new study also suggests that we may be completely wrong about the current estimated age and nature of our universe. David Gross, a Nobel Prize-winning astronomer, said, "We wouldn't call it a tension or problem, but rather a crisis." Let's delve deeper into this discovery and learn how the new Webb telescope discovery confirms a crisis in cosmology. In 1929, Edwin Hubble provided the first observational evidence that our universe is expanding everywhere. Using the largest telescope of the time, he discovered that the more distant a galaxy is from us, the faster it appears to be receding into space. This means that the universe is expanding uniformly in all directions. From this discovery, scientists thought that if the universe is expanding, then this expansion must have started at some time in the past, which means that the universe must have a finite age. And since the expansion is occurring equally everywhere, by accurately determining the expansion rate called the Hubble constant, the cosmic clock can be rewound and the age of the universe calculated. But before the Hubble telescope was launched, there was a huge uncertainty over the expansion rate of the universe, or Hubble constant. This value is needed to calculate the age of the universe, estimate its evolution over billions of years, and understand the forces driving it. When the Hubble Space Telescope was launched, it revealed that the universe could be as young as 9.7 billion years or as old as 19.5 billion years. But this younger value presented a huge problem. It would mean the universe was younger than the oldest known stars. Over the centuries, astronomers have adopted many methods to measure the exact value of the expansion rate. But surprisingly, each method has produced different values. It's as if the universe is expanding differently for different observations. Currently, There are two gold standard methods for figuring out the Hubble constant. The first involves poring over tiny fluctuations in the cosmic microwave background, an ancient relic of the universe's first light produced just 380,000 years after the Big Bang. Between 2009 and 2013, astronomers mapped out this microwave fuzz using the European Space Agency's Planck satellite to infer a Hubble constant of roughly 67 kilometers per second per megaparsec. In the second method, we use a Cepheid variable star or supernova as the distance source. As Cepheids get brighter, they pulsate more slowly, giving astronomers a means to measure their absolute brightness. By comparing this brightness to their observed brightness, we can calculate how fast the universe is expanding. But this is where the mystery begins. According to Cepheid variable measurements, the universe's expansion rate is around 74 kilometers per second per megaparsec, an impossibly high value when compared to Planck's measurements. Initially, some scientists thought that the disparity could be a result of a measurement error. But recently, Adam Rees, professor of physics and astronomy at Johns Hopkins University, said, "We've now spanned the whole range of what Hubble observed, and we can rule out a measurement error as the cause of the Hubble tension with very high confidence." Also, the new images of James Webb Telescope confirm that the previous measurements are correct, and the universe is expanding differently in different places. This dispensary in the value of the expansion rate of the universe suggests that perhaps the universe is not the same everywhere. Well, if this is true, then our standard cosmological model would fall apart, since we cannot estimate the age and size of our universe with different values of expansion rate. And the most important question that will arise is, what is the reason for the universe expanding differently at different places? One intriguing reason could be that dark energy, the mysterious force that seems to be driving acceleration of the expansion of the universe, is itself not uniform. In other words, dark energy is stronger in some parts of the universe than others, causing different expansion rates. Scientists claim that if the universe is not homogeneous and isotropic, then it would mean that the physical laws as we understand them are impossible to comprehend. Just over the cosmological horizon, the force of gravity might act in reverse, the speed of light might be slower than walking speed, and unicorns could be real. Well, this new discovery of the Webb telescope has caused a great debate among astronomers. This is because the non-uniform expansion of the universe challenges the cosmological principle, and it is one of the foundations of astronomy.